Hello, this is my English speaking practice and I'm working on coding problems and I'm gonna solve two problems in this stream. Let's go. Yep, reverse words in a string. Okay, given an input string S, reverse the order of the words. A word is defined as a sequence of non-space characters. The words in S will be separated by at least one space. Return string of the words in reverse order concatenated by a single space. Note that S may contain leading or trailing spaces or multiple spaces between two words. The return string should only have a single space separating the words. Do not include any extra space. Great. And S contains English letters, uppercase and lowercase, digit and spaces. Okay. There is at least one word in S. Okay, if the string data type is mutable in your language, can you solve it in place with? Okay, let's code it. But should I create a file? I'm not sure, but okay. Let's go. Let's go and by the way, I had mock interview today and yeah, it was second mock interview, my second mock interview, and I solved the problem. I could solve the problem, but the explanation was not good, so I have to practice. Yeah, and I got advice before coding it. I should write a pseudocode and explain it and write comment. Okay, so I will do it this time as I'm told. As the way I told. So let me clarify the problem. The string S contains English letters and digits and spaces. Okay, so we don't need to clean it up. Yep, and the naive solution be like split them, trim them and split by white space and reverse it. Okay, it is the naive solution. Yeah, trim it. So for example, this would be this, and split it by white space. Like this becomes like this, and reverse it. We can use a built-in function for to sort it. And finally, join it by white space. Okay, this is a naive solution, but I'm not sure. Yeah, I think this solution is not in place solution, because when we use split function, we need to allocate extra memory to store the element in the list. So I feel like this solution is simple and good, but the problem follow-up question requires us to solve this in place with extra constant space. So let me think about another solution. Yep, the trimming is still we still trim it. Yeah, trim it, and then we have to reverse it, and we need to find the separator. Separator is a white space, and we don't know how many white spaces are there between the words, so we have to handle it. And basically extra constant space. Okay, so the process is like using double pointer, and the pointer point to the head of the head word and the last word, and swap them. Okay, and yeah, so the challenge here is to find the words. Find the words and swap them. Okay. So we I will use 4 pointers. 4 pointers, or for example this case. For at the first we have 2 pointers at the both of side, and we are going forward in order to find the first word, and for the last word we have to go backward like this. Okay, and when we get the white space, we can fix it. Yeah, and we have 4 pointers, so we can identify the single word, 2 single words, and override it and override it. This is easy because we have index, so we can use slice. Yep. And the list, the string s is updated like this, and yep, we are going to find the next word. And we do it likewise. We do it in the same way, and we swap the word. Okay. And the pointer have to meet each other, so we can know the end. Okay. Yeah, so we can solve this problem in place solution. So just use 4 pointers, so it's a constant space. Okay, so let me code it. First, trim them, but I'm not sure trim is trim. Let me search. Strip. strip. Oh, this returns new trimmed string, so this is not in place solution. So we trim I trim it by myself because it's same as skipping white spaces, so we can do it. The left pointer would be, yep, left 1, left 2, is initialized, and R1 and R2 is oh wait, yeah, length of S is good because we use slice, so we have to point at the very end of the string S. So we can initialize 4 pointers like this, and S. And this R1 point to the left side of the word. Okay, so if so while L2 is less than R1, we going we process it, and step 1 we find the word. That means while L2 while S, the character at L2 is not white space, we move forward the pointer L2. Okay, and the word 1 would be L1 to L1 to L2. Oh, sorry. We have to handle the white space, leading white space. So L1 is white space. Not white space. As long as character at L1 is not white space, we move forward L2 pointer, and for leading white spaces we look at L1 and L2. So it is white space, we move it, we are moving forward, we move the pointer forward. Okay, yep. And also we have to keep the L1 value for at the first, because it's the it must be the starting point, and so we finally return the like this. So the start is fixed at this point, and we do the same for end of the word. So while R1 we can decrement. That means shifting left forward, shifting them left forward, shifting them to the left, and the end would be R2 plus 1. Okay, and find the word. And before we move the L2 pointer, we have to skip the multiple white spaces. There might be multiple white spaces, so we have to start at oh, it's so complicated. But it's okay. we do the same for the right word. R1, R2, R2, and we shift R1 the word 2, word 1 and word 2. We have 2 words, and word 1 might be equal to word 2. Yeah, if the number of words is odd, the word might be the same. So in this case, we do nothing anymore, just break this loop. Okay. Yep. And oh wait, it's complicated because when we have multiple white space, the starting index and ending index must be changed. So this solution is not good. Not good, because we have to remove white spaces, so the entire length might change. So find word and swapping them. Yep. So we cannot know the entire length until we finish the loop. Okay, so we cannot fix the position or indices for each words. That is a challenge. Yep. So we have to clean the original string at first. So that means we have to get the string like this. Every word is separated by single white space, and then we do this process. So so we are going to look at each character. When it's leading, start and end. Okay, if start is I or less, we can shift right the starting point. Otherwise, starting point. I'm confused. So this case 0, it read with white space, and we get C, and start is 0, and it's gonna be starting point, but it's white space. I see. Start. We do shift the starting point to the right. Okay. That's it. And otherwise maybe we have to like this, and end must start with 0, and we are updating it, and we have to reduce the number of white spaces. If they are multiple, they should be single. So when we find the white space, that must be the head of the white spaces. So this is so difficult because we have to copy the character. We have to override each character that appears after the multiple white spaces, right? So yep. Maybe there must be offset, and we have to count the offset. While we count the offset, it is the number of white spaces to be removed. Okay? Yep. Yeah. In this case, I point at this white space and I plus 1 point at first, and we go next. Yeah, we can go twice, so the offset must be 2, and the I point at here, but finally we have to move the I forward. Yep. And we get the character except for white space. We have to you have to update the character at I minus offset, and the character is that is C. Okay, and the end is maybe like this. Yeah, so for here we can remove the unnecessary white spaces, and so the entire length won't change from here. Okay, so we can do this process. We prepare 4 pointers, and we don't need to do instead we have already start and end pointer, so this start and end. Right? And we find the world. Yep. And the the S1 how about the other one is too long? mm, we cannot do like this because it's overwritten, so it's like done. So that's not good. I see. Oh, this is really difficult. In-place solution is so difficult. We have to handle the because when we write a new string, that might covers the other words, so we have to escape them. In-place solution. When we swap the word, it requires temporary variable because in Python we can swap at the same time, like this. That said, in this example, the size of words are not the same, so we want extra space. We want the extra space. Yep. I'm I give up. I give up this problem. In place solution would be difficult. It's difficult for me. Yeah. I have one naive solution for as a in place solution. We find the two words to swap, and we count the length of those words, and if the left words is smaller than the right words, we place it 1, 2, 3, 4, 5 like this, and oh wait, but this part would be removed. Anyway, we if we count the character one by one, we can do it. But the implementation would be so complicated, and I think this is not the expected answer, so I give up, and I want to see the solution. Yeah, this is ON solution, so this is not I want. I want to see the in place solution. Oh, this one. O1 space. Oh, this one. Reverse whole string, then reverse word in word by word. Reverse the whole string. Then we iterate characters in string S. For example, white, hello, white, world, white. Reverse the whole string. White, DLROW, white, space, OLLEH, white, space. Yeah. And fill the first word. So we move the first word shift left, because there is one white space, reading white space. So shift left, and the other part remains, and reverse the current word, then set space. So we can find these words, so swap from the reverse it and adding white space because that is the separator, and fill the second word. So we are going to look for the second word, and we can find OLLEH here and fill the second word. Okay, but wait. Yeah. If there are 4 or 5 white spaces, we have to count the white space in order to shift left the second words, and we do the same. We reverse the words. Reverse the word. Oh, this is smart. Reverse it, and we have I and K and N. Find the starting position of the next word. Yeah, this is what I did, and we are moving forward, I pointer I, and still have the next word on. Yeah. So the K is the end of the word, index for the end of the word. I is the index for the start of the word. Okay. Find the ending position of that word. K is going up. Reverse that word. Oh wait, what is it? This is not while. This is if I is not N, so there is still remaining characters, and K is larger than 0. K is larger than 0. The K is overwritten. Anyway, reverse it and IKN. Find the starting position of the next word. Yeah, this makes sense. So SI should point to the first character. First character of the word, but the word is reversed. And what is it? I might be n, but basically I is less than n, so, and k is larger than 0. I see. So this is a separator, and at first k is 0, so we don't have to do it. But basically when basically we add the word and we don't append the separator, so we have to, if we have the next word, we have to add a white space for separator as a separator. That makes sense. And the start index must be k, because that is the next position to the separator white space. So starting index is k, and I is also when I is what does the I point? Starting position of the next word. But the sk is updated to a white space, so I'm wondering si might be the white space, because sk is I see. K is less than I. In this case, after fill the first word, the K should point this one, right? And we have to update this cell to white space, because we have still next words, so we have to update white space as a separator, and then and the I must point here, at this point. Yep. And we have to shift the word to the left, so K point here and I point here, so we can shift them like this and going forward one by one. Okay, and if we get the white space, we stop it and reverse that word. This can be by starting index and k minus 1, because we know the starting index and k minus 1. Really? SLR k minus 1, really? Ooh. K is initialized here and going up, going up, going up. I see. So we don't need to use any offset. We use index. We use global index. So start index and k minus 1. That makes sense. That would be that point the head of the word and end of the word, so we can reverse it. This is a helper function to reverse the string. Okay, that makes sense. And after doing that, the k must point the white space that next to the end of character of the last word. So we can trim it, trimming the ending white spaces and join them. That means I see. We handle this as a list of characters, so we have to make it string back. Make it back to string. Okay. Yep. This was difficult for me. Yeah. But memory efficient. Okay, I see. And I was going to solve 2 problems in this stream, but it's time to finish. Yep. And I feel like I need to practice more English to explain. When I have a specific thought, I can explain it. I feel like I can explain it, but when I'm thinking about solutions and I haven't come up with the ideas, I don't know. I have no idea, and I have no idea what what should I say. So it's important to think in English, and yep. And also I have to increase vocabulary to connect words, connect sentences, or like that. So how do I do it? For example, this problem. But for this problem, I have already an answer, so I can explain this at a certain level. The problem is when I'm thinking. So how do I practice? Okay, I have an idea. I have tried this way. I explain something in Japanese as a natural thought process, and YouTube give me a transcript, so I will translate it into English later, and I can learn from it. Yeah. So let me speak in Japanese to learn how I speak in natural way.はい。というわけで日本語で解説しますが、この問題についてはすでに答えを知っているので簡単に説明ができてしまうということなんですが、できるだけ初心に帰って説明をしよう。まずこの問題の難しかったところは、インプレイスで、元々のオリジナルの、文字列を更新しなければならないというところでした。で、自分の取った戦略はポインターを2つ というか4つ用意して、先頭のワードと後ろから先頭のワードをそれぞれスワップしていくという手法でしたね。そのスワップをやろうとしていたんですけど、そのスワップをしようとするときにそれらのワードの長さが違うとかなり実装が複雑になるということに気づきました。それぞれのワードをスワップするときに長さが違う場合、長い方を書きに行くときに、もともとその小さい方のスペースでは足りないので他の部分に侵食してしまう、他のワードも上書きしてしまうという問題が発生しましたね。で、それの回避策として、ワードの数を数えて小さい方から安全に、スワップしていくとかを考えていたんですけど、小さい方から上書きしていくとかを考えていたんですけど、そのパターンも結局上書きをするときに、上書きされる側の、文字をどこかに退避しておかなければならないという問題が出てきて、その退避するスペースを確保してはならないという制約のため、それは結構難しいなというふうに思っていて、それに対する解決策が結局のところ浮かばなかったですね。なんとなく一文字ずつうまくやればできるのではないかという気がしないでもないですが、具体的な実装案も思いつかない上にかなり複雑になってしまうため、想定外ではないだろうということが、予測されましたし、そうですね、想定外ではなかったとしても綺麗なソリューションなら実装しようとは思うんですけど、綺麗でもなかったので諦めました。そして、ソリューションとして、そうですね、スペースコンプレキシティ O1、つまり定数スペースっていうのかな、定数スペースの開放としては、今ここに書かれているものになります。これはですね、大きく言うと、まずワードの順番をリバースする、ワードの順番を逆にする。いや、まずではないな。この問題の目的がワードの順番を、逆にするっていうことなんですけど、それをどうやるかっていうところで、工夫があると思います。まず最初に全ての文字をリバースするっていう、作戦をとってますね。これによって、語順的な、順序っていうのはアバウトに達成できるというか、全てを一回逆順にするという戦術をとっています。でこれによって、アバウトにっていうのは、その単語自体も逆になってしまってるんだけど、語順自体もリバースすることができているので、語順を逆にするという、部分は最初のリバースでクリアできているということですね。で残りはその今も単語自体も逆順になってしまっているから、 あとはその単語を、元に戻す作業をすればいいだけになっています。そうだな。実際にこれを説明するときは、多分このソリューションが思い浮かんだとして今から説明しようと思うんですけど、そうですね。例えば最初にスワップのソリューションが思いついたとして、ただスワップだと、余計なメモリを確保する必要があるということに気づき、そうですね。そうですね。スワップは厳しいということになりました。そしてなんやかんやで最初にリバースしてみようっていうアイデアを思いついたとして、はい、これはなんかいけそうだなっていう感触がここで、つかめるはず。最初にリバースすれば、このリバース自体はインプレースな関数なので、オリジナルのストリングをリバースすることができます。その状態を考えたら、語順自体はもうリバースされているから、残す作業はその単語一つ一つを、リバースし戻すことで、単語の語順は元に戻る。単語自体は元に戻る。語順はリバースされているという状態が作れます。はい。なので、あとは、そうですね。単語自体のリバースをインプレースに行うだけですね。もう一つ気をつけることとしては、ホワイトスペースが、複数個含まれているので、リーディングのホワイトスペースとエンディングのホワイトスペースもありますが、それらに注意してやっていくということだけですね。なので最初は、最初の文字の先頭を見つけるということで、そうですね。単語を見つけるためには2つのポインターが必要になるかなと思います。単語の先頭を指すポインターと、単語の終わりを指すポインターですね。なので2つのレフトポインターとライトポインターを用意すればいいかなというふうに思っています。そして、レフトポインターは、最初にホワイトスペース以外の文字が、見つかるまで、前に進んで、特定します。単語の先頭を。そして、その部分をスタートインデックスとして記録しておく。そして、そうですね。ここからがちょっとあれか。ここから考えないといけないこととして、最初の先頭はちょっと例外なんですね。先頭はちょっと例外で、ちょっとノーマルケースを考えてみます。ノーマルケースは、何か一つの単語の、リバースを終了した後の話ですね。終了した後、セパレーターとしてホワイトスペースを一つ追加します。はい。で、そのホワイトスペースの次の場所に書き込むべきという情報が得られます。なので、単語の開始位置とか単語の、そうだな。その単語自体の開始位置、終了位置自体は関係なくて、書き込み位置は前の単語の終了位置に依存しているので、その辺のポインターをうまくハンドルする必要があります。でも、結局前の単語の終了位置に依存しているので、単語の先頭と終了を指すポインターが2つあれば、なんとかうまくいくかなという感じですね。なので、最初に単語の先頭を見つける。その後、前の状態のエンドポインターが書き込み位置を示しているはずなので、その2つがセットになります。はい。先頭を指すポインターから、書き込み先頭位置にシフトするような処理をしますね。 で、あとは簡単で、その単語の数だけ、ポインターを一つずつ同時に進めていけばいいので、進めていきます。で、ホワイトスペースが見つかったら、終了しますね。はい。これだけですね。はい。これだけですね。で、一番最初のケースはどうなんだろう。一番最初のケースは、単語を見つけに行くんですけど、えっと、そうですね。この場合、リーディングスペースを無視するというより、一番先頭に書き込みを行うっていう考え方にすれば良さそうなので、デフォルトの書き込み位置は0になってます。それで OK です。それで全てがうまくいくはずで、最後に単語を書き終えた後は、元のストリングから比べると、ホワイトスペースの分シフトしているので、あまりのスペースが生じているはず。ホワイトスペースがいくらか生じているはずなので、ホワイトスペースというか、不要な部分がいくらか生じているので、最後に書き込んだポインターを、そのストリングの最終的な終了位置としてスライスなどを使って、切り取ればいいという風な形になっております。はい。リバースしてなかったな。その単語の先頭位置と、書き込み位置が分かった段階で、これどうなってんだ。はいはいはい。シフトさせた後にリバースしてるのか。はい。そうですね。シフトして、単語の文字が逆に並んでいる状態でシフトした後に、その単語自体の範囲っていうのが分かっているので、その部分をリバースすることで元の単語に戻るということになっています。こんな感じの実装で、いけると思います。スペースコンプレキシティは、説明の通りインプレースで行われますので、定数ですね。O of 1で進みますと、タイムコンプレキシティは、リバースも線形だし、このメインの while ループも文字を一個一個見ていくものになります。リバースがあるからどうなんだこれ。while で、基本的にポインター i がすべて一文字ずつ見る一文字ずつ見ると、でリバースがあるんですけど、これはそうですね。基本的に、全てのワードで行われるので、n プラス n みたいな感じになると思うんですけど、最終的には、O of n ということになります。はい。以上ですね。O of n で合ってるよな。はい。っていうのが日本語で言った場合の説明なんですけど、ちょっとこれをもう一回英語で言える？Hi, this is my solution, and finally I came up with this solution. Yeah. at first I thought swapping the words, and yeah, I'm looking from the left one and right one, and I wanted to swap those words. But when swapping them, we need extra space to to copy the words, because we have to overwrite the word. So we need to escape characters um, in the area where we are going to overwrite it. Okay, so swapping is not good. Yeah, and yeah, I'm thinking about swapping, and I'm thinking about swapping one character one by one, and but that would be so complicated, and it's not beautiful and not smart. So I think this is not not expected solution. Yeah, I believe there must be a better solution. Yeah, so and I was thinking about another solution, and yeah, I yeah I reversed the string at first, and I realized, oh, the order of words are reversed. Yeah, that's it. But the problem is the word itself is reversed as well. So that is not a valid word. Yeah. But I feel like I can do it because the order of words is already solved. So yeah, so we have to do is reversing the word, and yeah, so reverse the word back to the original word. Yeah, so we have to identify the word and reverse it. That's it. Yep. Yeah, and another challenge is to handle white spaces, because there might be multiple white spaces, so we have to handle it. Yeah, when we update the original string, so we have to care about the index. Okay, so the basic idea is to identify the word and reverse it. That's it. So we use two pointers, and first one point the head of the word, and the second one points the end of the word. Yeah, that's it. And the implementation is like this. And so first we are looking for the non-white space. Yeah, and we move the first pointer until we look at the character, and as I said, the second pointer points to the end of the word, but however, more rather than end of the word, it point to the place to to write the character. Okay, so I mean, if I update the word, we have to append the white space at the end of the word, okay, because that is the separator. Yeah, and we have to overwrite, we have to start to write the next word at the place next to that white space, okay, because we required to separate words with single white space. So when we overwrite the word, we append the white space, single white space, and we start to write next word. Yeah, so the second pointer point to the end of the word, and also we move it once, and we write a white space, and we move it once, and the second pointer point to the place to write. Okay, so this is the main process, and we do it in this while loop. And yeah, and since we have 2 pointers and start head of the word and the place to write, okay, so we have to, we just move the character, yeah, and then we reverse the word, okay, that's it. Yep. And for time complexity is it would be O of n, where n is length of string, okay, because we visit every character in main process. Yeah, basically we visit the character twice. For I, we iterate through the original string, so we visit once for that, and we also reverse it, so yeah, it ends with visiting twice. But so its time complexity is like n plus n, yeah, but yeah, the time complexity is regarded as O of n. Yeah, so this is linear algorithm, and the space complexity is O of 1. It's constant. We only use constant extra space. Yeah, that's all. Okay, finish. Thank you for watching.